Hey friends, we're now talking about lesson 6.2, which is the properties of a parallelogram. Now, remember parallelograms are a very specific type of quadrilateral. They have two pairs of opposite sides parallel. But what I want to talk about is our quick review from lesson 6.1, the definitions of the different quadrilaterals. Remember, what is a rhombus? It's a quadrilateral with four congruent sides. All right? What's a rectangle? A quadrilateral with four right angles. A square is quadrilateral with four congruent sides and four right angles. What's a trapezoid? And I'm going to do the visual for this one. A trapezoid has exactly one pair of opposite sides parallel. And then we have our isosceles trapezoid, which is we have our opposite sides parallel plus the non-parallel sides being congruent. So those are just some of our specific definitions. Those are good to review over and over every night because that's a big definition section because it's all definitions just from that lesson. There was no theorems. Some terminology we want to make sure you know. Opposite sides and opposite angles. Now that's different than in a triangle, okay? Now opposite sides of a quadrilateral do not share a vertex. So they literally mean they're across from each other. Same idea with opposite angles. They don't share a side. So that means they're the angles. They don't have anything in common. Now there's stuff in common with them, but when I mean like that, they don't share a segment in common with each other. So some terminology we need to know. All right, let's review what a parallelogram is. It's a quadrilateral with two pairs of opposite parallel sides. Now please don't forget now all the rules of parallel. If I have parallel lines, then corresponding angles are congruent. If I have parallel lines, then alternate interior angles are congruent. If I have parallel lines, then same side interior angles are supplementary. All those things come in handy. So when we talk about parallelograms, please don't forget some little details that would be very helpful for us. One of those things is you should always mark the opposite sides parallel. Always remember we have a symbol for parallelogram. It's going to be the little parallelogram box. Huge thing. So the first property that you really need to know is in the definition. All right, so that's the first thing we need to know. Opposite sides are what? Are parallel. Now guys, think about that. That now makes A and B same side interior angles. That makes A and D, if you do the same thing, look at the C shape. Same side interior angles. Notice everything from chapter 3 is now coming back together in chapter 6, so we're going to have to know those. So we're going to be practicing our properties, and I'm going to ask you to list them over and over again because we're going to have like a 4-week break, and then I'm going to still expect you to come back and remember these when you come back in January, so make sure you know these really well. All right, let's do our second property here. If a quadrilateral is a parallelogram, then its opposite sides are congruent. And the really reason why that works is because we know the opposite sides of a parallelogram, you know, they're going to always be the distance away if they're parallel, but the way I'd prove it is I would draw in a single diagonal. And with that single diagonal, I would draw in my alternate interior angles because I had my parallel sides, and I'd have my reflexive property. So by angle, side, angle, those two triangles I just drew are congruent. And so then what do I know about corresponding parts of congruent triangles? That's right, they're congruent. Now there is a shortcut way that I actually write this property out. I would just say a parallelogram implies opposite sides are congruent. So if you say that, I'd be exactly great. It's a shortcut way. All right, so here's your second property. See if we remember the first one. The first property, opposite sides are parallel. Second property, opposite sides are congruent. Now that's of parallelograms. Now we're going to keep going here, and we're going to do it on the next side. Third property, okay? If you have a quadrilateral that is a parallelogram, then its opposite angles are congruent. All right, which tells me then, and let me see if I can do this because this was in color when I wrote this, B and D are congruent, A and C would be congruent to each other. So we could write that in shortcut way also. If I have a parallelogram, opposite angles are congruent. Again, this would be proven using congruent triangles. So that's our third property. So let's do a quick review again. First property, opposite pairs of sides are parallel. Second property, opposite pairs of sides are congruent. Third property, opposite pairs of angles are congruent. Let's do our fourth property. And this one's because of parallel lines. If a quadrilateral is a parallelogram, then its consecutive sides, or excuse me, I just said that wrong. Consecutive angles is what I wanted to say, are supplementary. Now the reason why this works is because of same side interior angles. Because if I was to extend one of the sides, do you guys see the pair of parallel lines with my transversal? Those are same side interior angles. Same side interior angles are what? Same side sup. That's right. So that's using those. And I could turn it around doing the same thing over and over again. So the consecutive angles, which means one right after each other, are supplementary. That's your fourth property. So make sure we know that one. And I'd even sit there and say, if parallelogram, consecutive angles are supplementary. Now, just warn you, on Tuesday when I come back, not on Tuesday, excuse me, when I work this in class, you're going to hear me repeat this over and over again, so you're kind of lucky on the video I'm not being overly obnoxious, but these have to be in grade, kind of like what we did with CP, CTC. You need to know them, period. There's no other way around it. All right, and then we have our next one. A quadrilateral is a parallelogram, then its diagonals, remember those are the ones that go across, bisect each other. So the diagonals bisect each other. That means these two segments are congruent and these two segments are congruent. Now how would I prove that? Trust me on this one again, congruent triangles. Because we know what we have about parallelograms, we could actually use congruent angles and vertical angles and use angle side to show it. So once again, we have congruent angles. So what is that one? Our fifth property. All right, let's do a quick repeat again. Number one, opposite pairs of sides are going to be parallel. Number two, opposite pairs of sides are congruent. Number three, opposite angles are congruent. Number four, consecutive angles are supplementary, same side, sup. Fifth one, diagonals bisect each other. You have to have those things memorized. And if you memorize it like I just did, it's really easy to apply these. So let's go ahead and we will start working several examples together.